Interval of convergence. What is the interval of convergence of x minus 3 to the n over n 3 to the n? Okay, so it looks like we got two things going on here. So we got a geometric series and then a harmonic series. So I'm going to rewrite this real quick as, so we have 1 over n. We also have x minus 3 over 3 to the n. So a geometric series, whoop, whoop, right here, little summation symbol. Oh, that is terrible, tragically bad. N equals 1 to infinity. So for a geometric series, one of the things you kind of have to be careful about. So backtrack, slight review. If we have a geometric series with, let's say, r to the n of n equals 0 to infinity, this will equal 1 over r to the n plus 1, or 1 minus r to the n plus 1 over 1 minus r. And so for this is what the value of a geometric series will be. We can actually find the actual value of it. So if we want to find the value, we need to start at 0. So this series over here starts at 1. So if we wanted to find the value of the geometric series part, then we'd have to add in that extra term, which we can do. It's not a big deal. But in this case, we're not really concerned about the value of it. We just want to make sure it has a value, because this convergence isn't what does it equal, it's does this equal infinity or not equal infinity. And long story short, you can kind of sort of look right here and see that, all right, if this r is less than 1, then that to infinity will actually go to 0. So the goal here then is you want to have this x minus 3 over 3 less than 1. That way it will go to 0. So for this, to have x minus 3 over 3 less than 1, x minus 3 then is less than 3, x is less than 6, but also it can be greater than negative 1. So x minus 3 over 3 greater than negative 1, x minus 3, whoop, greater than negative 3, x is greater than 0. And the reason you can do negative 1 is because if you have negative 1/2 squared and then cubed and then to the 4th, it'll keep getting smaller and smaller and smaller. So that is the idea with the geometric series part. So to have this converge, it's going to be between 0 and 6, because we want this term right here to be between negative 1 and 1. So now the question becomes, all right, what about the endpoints? We determined that it's between 0 and 6. Actually, I should probably check out what the possible answers are. So if we come over here, yeah, they're pretty much all 0 and 6. So we have limited it down to 1 and 3, which isn't bad. Okay, so now the question is, what about the endpoints? Do they work or not? So if we put in, let's start with 0. If x equals 0, then we'd have negative 3 over 3 to the n, which equals negative 1 to the n. Basically, it alternates back and forth between negative 1 and positive 1. Now, if x equals 6, then it would be 6 minus 3 over 3, and that would equal 1. And 1 to the n then would just be 1. So basically, it'd be as if it didn't exist. So we can write this, because we're only looking at two terms here, 0 and 6. We're looking at the endpoints. So if we do this for n equals 1 to infinity of 1 over n to the negative 1 to the n, and we have 1 over n 1 to the n, which this is 1. This is for x equals 6. This is for x equals 0. So this then is the harmonic series. The harmonic series does not converge. That's just something you memorize. 1 over n does not converge. It's kind of famous. I guess if it has its own name, then it makes sense that it's famous. But there's also another test called the alternating series tests. And the requirements for the alternate series test is the series has to go to 0. So 1 over infinity does go to 0. And it alternates back and forth between 1. So this would be, let's see, for the 1 would be, so we have negative 1 plus 1/2 minus 1/3 plus 1/4, so forth and so forth. And the signs would alternate. So the harmonic series, when it alternates, actually does converge. So this will converge. This will diverge. Now I think there's D-I-V-E-R-G. Yep. So we want to include 0, but not 6. Right. So that is this one right here. This little bracket means includes, and this little parentheses means does not include. So this isn't true because 0 will make an alternating series test, and we want to include 0. This one is wrong because it includes 6, and 6 would not alternate. So 0 and 6 is the right answer.